Hi, in this video I would like to solve a complete exam provided by MIT Open Course. The test is for the topic of single variable calculus, or what we call it in most of the universities as Calculus 1. So what I will do is I will solve each question and provide hints and tips and tricks about solving this kind of problems. So problem 1. Find the tangent line to the function y equal to 1 over 3x squared at x equal to 1. So let's check quickly how the function y equal to half x squared or 1/3 x squared looks like. So the function looks like this, and at 1 there will be a point which is 1/3. So they are asking us to find the tangent line to this point. So you can see that the slope is positive. First, we know that this line has a model y equal to mx plus b, where b is called the y-intercept and m is the slope of that line. But we know that the slope of the tangent line so the slope m is equal to the derivative of the original function, which is this one, y equal to x squared divided by 3, evaluated at x equal to 1. So we're taking the derivative d by dx of the function x squared divided by 3 evaluated at x equal to 1. So if you perform the derivative using the derivative rule, remember we know that the derivative d by dx of the function x to the power of m is equal to m times x to the power of m minus 1, and also the derivative of a constant multiplied by a function. Also remember that the derivative of a constant c multiplied by a function f of x is just equal to c times the derivative of that function. So the constants goes out the differentiation. So this will be equal to 1/3 times the derivative of x squared, which is 2 times x to the power of 2 minus 1, which is 1, evaluated at x equal to 1. So the answer will be 1/3 times 2 times 1, which is just 2 over 3. So the slope here is equal to 2 over 3. Now how to find the value b? To find the value b, you need a point on the curve that touches the line as well. okay, which is this one. How do I find it? I find it from the original function. So you look here, we know that this point, when x is 1, y is 1/3. So I use this to plug it in this equation. So we know that the line now, the tangent line equation, so we call it yt, tangent line is equal to m x plus b, but m is 2/3 x plus b. Now plug in the point 1/3, which means that when when x is 1, y is 1/3. So you can take this to the other side, and then you will have b equal to 1/3 minus 2/3. So b equal to minus 1/3. Therefore, the final equation yt is equal to 2/3x minus 1/3. And that's the final answer. Now let's solve question number 2. They're asking us to find the derivative of the following functions. So how do we calculate the derivative? So let's call this function y. So the derivative on y can be expressed, so to make things easy, you can express this as either f divided by g, where f is equal to x and g, the function g, equal to √1 minus x. And then use the quotient rule, which says that d by dx of f over g is equal to g f prime minus f g prime divided by g squared. That's one way to do that. So this is the first approach. The second approach is you call this, or you bring this up, and it becomes y equal to x times 1 minus x to the power of minus 1/2. So remember that the power, when you bring it up, changes from positive to negative. So these are very important rules. So I'll just write it down here. Remember, that when I have 1/a to the power of m is equal to a to the power of minus m. So √1 minus x, or 1/√1 minus x, is equal to 1/1 minus x to the power of 1/2. When you bring it up, it becomes 1 minus x to the power of minus 1/2. So, and now you can express this as f times g, and this will equal to f times g. So the derivative of f times g is equal to f g prime plus f prime g, and that's approach number 2. So whatever is easy for you will be, acceptable. Both ways are acceptable. So let's actually find the derivative using this function, question number 2. In equation number 2, we need to find g prime and we need to find f prime. So f is given by x, so the derivative is simply equal to 1. However, g of x is equal to 1 minus x to the power of minus half, so the derivative is given by g prime of x is 1/2 1 minus x to the power of minus 3/2. How do we do that? We use the so-called chain rule. How does the chain rule work out? So you can see that directly we don't. So this looks like g of x looks like a function similar to something like u to the power of minus half. Okay, so in this case u here is another variable given by 1 minus x. So you can express g of x as u to the power of minus half, or u equal to 1 minus x. So in this case, the derivative g prime is equal to dg by dx is simply equal to dg by du times du by dx. So dg by du, the derivative of g with respect to u, is just simply minus half u minus half minus 1, the polynomial rule, times du by dx is just minus 1. So minus 1, the minus becomes positive, and this is equal to minus 2 over minus 3/2, and the final answer is just u to the power of minus 3/2, and substituting u, which is 1 minus x, there is 1/2 here, this is equal to 1/2 1 minus x to the power of minus 3/2. So that's g prime. So we found g prime, we found f prime, which is 1. Then you can just plug in the values here. So that will be f, which is x, times g prime, which is 1/2 1 minus x to the power of minus 3/2, plus f prime, which is 1, times g, the original g, which is 1 minus x to the power of minus half. So rearranging the terms, that would be x/2 1 minus x to the power of minus 3/2 plus 1 minus x to the power of minus half. And that's it. Now question B. So this is equal to y, which is given by f divided by g. So we use the quotient rule to say that the y prime, the derivative, is just f prime g minus f g prime divided by g square. So let's see, g is given by x, so if g equal to x, then g prime equal to 1. If f equal to cosine to x, then f prime is equal to 2 minus 2 sine 2x. Again, this is done using the chain rule. So we know that if you let u equal to 2x, then we have f equal to cosine u. So du over dx equal to 2, and df by du equal to minus sine u. So in this case, df by dx is equal to df by du times du by dx. So the answer will be minus 2 sine u, but u is just 2x, you plug it back, minus 2 sine 2u. So now let's plug the values back. F prime is minus 2 sine 2x, and g is x minus f, which is cosine 2x, and g prime is 1 divided by g square, which is x square. So the final answer will be minus, open a bracket, this is a common factor, that will be 2x sine 2x minus cosine 2x divided by x squared. And that's it. What about question C? So find the derivative of this. So again, here we have to use the chain rule. So remember that g equal to e to f. So what we say that let u equal to 2f. Okay, then we have g equal to e to the u. Now du by dx is simply 2 times df by dx. Now here dg by du is simply equal to e to the power of u. Therefore, we can use the chain rule to say that dg by dx, that's the derivative, what we are looking for, is simply equal to dg by du times du by dx. So dg by du is equal to e to the u, but u is 2f, so e to the power of 2f times du by dx is just 2 df by dx, and that's the final answer. The final question here, part D, which says y equal to ln sine x. So find the derivative of y equal to ln sine x. So in this case, we again use the chain rule. So we let this equal to u. So we have now u equal to sine x, and we have y equal to ln u. And the chain rule says that dy by dx, the derivative, what we want to calculate, is expressed as du dy by du times du by dx. So we need to find du by dx is equal to cosine x, and dy by du is simply the derivative of ln u is 1 over u. So the answer will be 1 over u times du by dx, which is cosine x. But then we have to substitute back the u here. So the final answer, dy by dx equal to cosine x divided by u, which is sine x, and that's equal to cotan of x. That's it. Now what about this question? Find the derivative for the function y defined implicitly by this, and they want to calculate the derivative at the point x equal to 3, y equal to 1. And x and y are two variables related by this relationship. This is a non-linear relationship, and it's not explicit, it's implicit. So you cannot separate, cannot be written, implicit expression cannot be written in the format y equal to f of x. Okay, this is the problem. So we cannot do that. In this case, there is a way to take the derivative. So this is using chain rule. So we need to take the derivative d by dx of y to the power of 4 plus x times y. So if you take the derivative in one side, you take also the derivative on the other side. So what's the derivative of y to the power of 4? This is using chain rule. Okay, so this is given by 4 y to the power of 3. So you use the normal power rule in the derivative times the derivative of y, which is dy by dx. Okay, so this is using the chain rule. Then the derivative of x times y, it's the derivative of the product. So plus the derivative of the first, so d by dx of x times y plus x times the derivative of y by x equal to d by dx of 4. The derivative of a constant is just 0. Now remember, we need to find the value of the derivative. So the derivative dy by dx appear here. D by dx of x is just equal to 1. Okay, so we need to plug in the values of y and x from here. X is 3, y is 1. So if y is 1, then y cubed is 1. So first I have 4 dy by dx. So 4 dy by dx, the first term. The second term, this is equal to 1. One times y, and y is equal to 1. So 1 times 1 is just 1. Plus 1 times 1. Plus here x is equal to 3. As you can see, so 3 times dy by dx. So 3 dy by dx equal to 0. So now let's combine the like terms. So 3 dy by dx plus 4 dy by dx. This gives me 7 dy by dx, and this is plus 1 equal to 0. So dy by dx 7 equal to minus 1, and then dy by dx equal to minus 1 over 7. And that's the final answer.